changing. If I want to, then we keep changing. Where did we stop? Where did we stop?
Log.
Logarithm, not so?
Yes.
And we are looking at, we said logarithm is another way of expressing numbers, in power form, okay?
Yes.
Yes.
And there are very many ways we can use for reading logarithm. One of them is we can use log table, or we can press it direct from our calculator. And we said the log table we have and the calculator we have all have been programmed to log to base what? To base 10. Log to base what? To base 10. And that one we call it common. Is called what? Common what? Common what? Common logarithm. It's called common what? Logarithm. That is good. That is called common what? Logarithm. And we went ahead and we look at how we can express logarithms, how to express logarithms. And people submitted their work. Those who submitted, that is good. Those who still want to be pushed to do work, please, I'm sorry. I'm sorry for you, please. Do the needful, okay?
Yes.
You people, you know me very well. You know me very well. I don't need to keep explaining myself to you. You know who I am very well. Okay?
Yes.
Then there's one thing I also have discovered when we are writing standard form or scientific notation. Scientific what? Notation. We said when you are writing numbers, you said is a to the power what? N, okay? Yes. And we said this one must be a single digit. Must be a single what? Digit. So now if they have given you, like example, the one that I gave you in the question, it was what? 6.23, not so? It was 6.23. Now they are telling you to write this one in standard form. This one in standard form is just going to be the same as 6 because the number before a decimal point is only a single digit. So it's already 6. So it's going to be 6.23. How many steps have you moved? Have you moved any step? Have you moved any step, members? No. So yeah, if you have not moved any step, which means it's going to be to the power what? 1. To the power 0. You have not moved any step. But if it was 62.3, 62 point what? 0.3. So this one is going to be 6.23 times 10. How many steps have you moved? How many steps have you moved? 1. You have moved only 1 step. I see that. But if it was 623, what is it going to be? If it was like that, what is it going to be? It's going to be 6.23 times 10. How many steps do you need to move? 1, 2. I see that. So which means to the power what?
2.
Members, have you seen that? Members, have you seen that?
Yes, teacher.
Yes. Take note of that. Take note of that. Take note of that. Now, what we did at that time, we were looking at how to read logarithm, how to read what? Logarithm. So let's write this one. Note. Logarithm is not on the screen, members. Logarithm is a system. Is a what? Is a system of evaluating multiplications. The system of evaluating multiplication, division, powers, and roots. Power and what? Power and roots. By appropriately converting them by properly converting them to addition and what? And what?
Multiplication.
And subtraction, addition and subtraction. Okay? If you
Yes.
remember, members, I said if I have log to base A of B equals to C, we said A is called what? A is the what?
Base.
Base. Then B is called what? B is called what?
Argument.
B is called argument. Good. B is called argument. Then C is called what?
Power.
B is the power. Good. Or what? Or exponent. Or what? Exponent.
Exponent.
Now, members, we have seen how to get logarithm of numbers that can be expressed in power of 10 in the power of what? 10. We said, take for example, log to base 10 of what? 100. We said the answer is what? The answer is what?
2.
Is 2. Log to base 10 of 1000. The answer is what?
3.
3. Log to base 10 of 10,000. That one, the answer is what? Is it?
4.
Is 4. How did we work out that? That one, we have worked them out. Those are the numbers which can be expressed to the power of what? To the power of 10. To the power of what? 10.
10.
And we also went ahead and we saw also how to get logarithm of numbers between 1 and 10. Between 1 and what? 10.
10.
That one we said, what do? You get those one from where? Either from your calculator or from where? Or from the log table. Okay?
Yes.
Yes. Now, just to remind ourselves, how to read a log table. How to read a log what? Table. And this is for numbers. For numbers between what? Between 1 and what?
1 and 10.
1 and 10. Remember, if I talk of 1, remember we said log to base 10 of 1 is what? Who can remind us? What is log of 1? What is log of 1? I remember we discussed it at that time. What is log of 1?
0.
Log of 1 is what? 0.
0.
And log of 10 to base 10 is what? Is what? Is 1. Okay?
1.
So which means the only logarithm we are interested in is between 1 and 10, like 1.2 up to 9.9. How do we read those logarithms? From the log table. Okay? This one we have understood them from theoretically. I said the man who discovered logarithm is called who?
John Napier.
John Napier. Good. John Napier. Is a what? Is a Scottish. Is a what?
Scottish.
Is a Scottish. So let's see how we can read log from the table. From where? From the table. Using log table. Let's read log to base 10 of, let's say, 5.692. Members, that's what we have. That's what we what?
We have.
And most of them are to 3 decimal places. Maximum, we can write them to how many decimal places? To 3. But when we are writing the logarithm of that particular number, we write it to how many decimal places? We write it to how many?
4 decimal places.
We write it to 4 decimal places. But the number must be to how many decimal places? To 3 decimal places.
Decimal places.
If it is more than 3 decimal places, if it is more than 3 decimal what? Places, you read part by part. You read part by what?
Part.
Now, let me take you to my log table here. Are you seeing my log table there?
Yes.
This is for numbers between 1 to 5.4.
9.
9. So is our answer, is this in the range? Or ours is it 5.6, 5.6, 5.6. This one is not there, not so?
Yes.
Another one is coming here. Have you seen it? Have you seen it?
Yes.
Yes.
Is there. Is there. So which means we are going to, I said you what? You read what? 5.6 under what?
Under 9.
Under 9.
Under 9.
Then add what?
Add 2.
Add 2. So what is 5.6? Let's read what is 5.6 under 9. I think 5.6 from our log table there. 5.6 where I've written number. I think it.
Yes.
Yes.
5.6 under 9. What is that answer?
0.755.
Is 0.755.
755.
Have you seen that?
Yes.
Then what are we adding? We are adding 2. We are adding 2, but you see that now this log table we have here does not have a what? A column for add. Are you seeing that?
Yes.
So which means
Yes.
if they give you something like that, you round it off. You what?
Round
Round
it
it
off.
off.
You round it off. It depends on the table you have, but the one that you have, you use only for your name. It has that part of add. Okay?
Yes.
Yes.
Yes. So which means for this case, what are we going to take? Because when you round off that one is the same as log to base 10 of what? 5.69. Are you seeing that? Members, have you
Yes.
seen that?
Yes.
Yes.
So which means we shall say log to base 10 of 5.69 is equals to 0.7 what? 55.
55.
Remember I said they must be written to how many decimal places? To 4. To 4.
4.
Now, what you do, you add what? You add 0 to
0.
that to make it what? To 4 decimal places. Have you seen that?
Yes.
Yes. But if you from calculator, this is now from the calculator, from the what? From the calculator, you can press this one direct in your calculator, 5.692. What do you get? What do you get?
0.755.
Log 5.692. You get 0. What? 755 what?
3.
3 to 4 decimal places. I think that.
Yes.
Yes. So you see the difference is not big. The difference is not what?
Big.
It's not big. That is number 1. Number 2, you read for me log to base 10 of 8.87. Who can read for me that? From the table you are seeing there. Let me take you 8.8. Are you seeing 8.8?
Yes.
8.8 under what?
Under 7.
Under 7.
Maya, what is taking place in your background? What is the answer, members? 8.8 under 7. What answer do you have? From the table, read for me from the table.
0.947.
9 for what?
7.
9. You check well here. We are adding 7. Are you seeing that?
9 for 8.
You follow 8.8. Is 4.8, not so?
Yes.
You press that one direct from your calculator. What do you get? Press it direct from your calculator. Log of 8.87.
0.947. 9.
You see, when you press calculator, you get 0.7. I mean 0.947. I think that.
Yes.
Yes. Takes note of that. Takes note of that. So That is for numbers between what? Between 1 and
10.
1 and 10. Is there any question on that, members?
No.
Okay. Let's look at for numbers which are greater than 10, subheading. Logarithms of numbers greater than what? Greater than 10. Greater than 10. How do you read them? We say numbers that are greater than 10 are first expressed in standard form. So you have first to express these numbers in standard what? Express the number. Express the what? The number in what? In what?
Standard form.
Standard form.
In that standard form. Then after expressing that, then you can now go and read from the table. Then you can go and read from the what? From the table. We said numbers that are greater than 10 are first expressed in standard form in order to get their what? Their logarithm. Their logarithm. That one we have already discussed them. How to write number in standard form. Then we said the laws of indices are applied. The law of indices are what? Are applied. Good. So take for example, let's look at some examples. Number 1. They're saying find the logarithm of, we have 27 point what? 0.4. We have 27 point what? So what is this one in standard form? This one is going to be 2.7.
7.
How many steps have you moved? How many steps have you moved? 2 steps. How many steps? 2.
1.
Only 1. Only 1 step. 1 step. From the point here, we have moved only 1 step. Okay?
Yes.
So now we have 2.7 what? 4 times 10 to the. Now we have to express this one. Are you seeing that? We go to our table and then we read log. We read log to base 10 of 2.7 what?
4.
Remember, once you, after reading this, the answer you are going to get is going to be to the what? The base is going to be to what? To 10. So it's going to be 10 to the power. The answer that you are going to get, you are going to put to the power of 10. Are you together, members?
Yes.
Let's go back to our. I'm saying,
Yes.
when you have this, like what we said, like take for example, if I have log of, this is our side work, log of 100. We say the answer is what?
2.
Is 2. This one is the same as 10 to the power 2 is equals to 100. Not so?
Yes.
Do you remember that?
Yes.
Yes, because logarithm, when it's into the base 10, is giving us the number to the power of 10s, to the power of what? 10.
Of 10.
So that's why we are writing it like this. So which means the answer you are going to write here, because this is going to give us the what? The power, not so. This one is going to give us the power. So the power must be to the power of what? To the power of 10. Have you seen that?
Yes. Yes.
Now let's go back to our table. Let's go back to our table. He's here. 2 point what? So we're going to read 2.7 under what?
4.
What do you get? What do you get? Just use your calculator. Just use your calculator. If you cannot see the table well, use your calculator and give me the answer. But it must be
0.436.
0.437 what? 8. That one is to 4 decimal places. Like that, not so? Now, remember what you have got. You have got only for this one for 2.7 what? 2.74. So what you do, let me open mine. So you are going to say log to base 10 of 2.74 is equals to 10 to the power what? 0.4378. Okay? Remember when I was looking, so Simon said, implying that log to base 10 of 27.4. 27 point what? 0.4 equals to, when we express it in standard form, what did we get? We got what? 2.74 times 10 to the power what? 10 to the power 1. Not so?
Yes.
So which means now, so this one is still log, sorry, foot log there. So which means log of 10, 2.74 times 10 to the power 1. Members, what we are doing, we have expressed this one to the power of 10. Why do we have to do that? So that they have the same base, so that we can add the what? We add the powers. We said when this number have the same base, what do? We add the what? The powers. So this one we got, gave us 10 to the power what? 0.4378 time 10 to the power what?
10 to the power 1.
Now you see that they have the same base. Do they have the same what? Base. So
Yes.
apply the law. Apply the law of what?
Indices.
Apply the law of indices there. So when you apply the law of indices, what do you get? The base is the same. So which means I'll have 0.4378 plus what? Plus 1. Plus 1. What do you get? We get 10 to the power 1.4378. So what does it mean? Therefore, log to base 10 of 27.4 is equals to 1.4378. If you look from our table does not give 1 point. Our table gives 0 point. I think that.
Yes.
Yes. So for numbers which are greater than 10, we first express them in standard form. We first express them in standard what? Form.
Standard form.
Now, members.
Yes.
Yes.
Now you press it direct from your calculator to confirm our answer. You press it direct. Just press log of 27.4. Not so? Are you seeing it there?
Yes.
What do you get? You get what? 1 point?
1.4378.
Is it different? Is it different?
No.
No. I think that this one we have used method. This is the method, but this one we are just proving our answer. Have you seen that?
Yes.
Let's go back here. Let's go back here now. B. We have 300. Find log. Just saying log to base 10 of 382. Okay? We said, what do we do, members?
Change it to standard form.
So you first express 382 in standard form, which is going to be what?
3.82
times 10 to the power. How many steps have you moved?
2.
2 steps. Now this one, I'm going to give you the name. I will tell you later, okay?
Yes.
But we said this one is called what? This one is called what? Argument. That one is called argument. Good. So which means I say log to base 10 of 832 is the same as log to base 10 of 3.82 times 10 to the power what?
2.
Times to the power 2. So which means when I break this one down, when I break this number down, so it's going to be the same as log to base 10 of what? 3.82. I think that? Plus log to base 10 of 10 to the power what?
2.
2. Have you seen that?
Yes.
Go to your table. Go to your what?
Table.
What is 3.82? Read for me 3 point what?
8.
3.8 under?
2.
Under 2.
What do you get? I said, if you cannot, just press for me direct from your calculator. Just press for me direct. If you cannot see the table. I know some of you are using phones, so they can't see the table well. Just put your calculator. Is 0 point?
581.
0.5.
0.581.
2 what? 21. Not so.
Yes.
Uh-huh.
8.
Plus what? What is this? This is what? This is what?
2.
2, not so?
Yes.
Yes.
When you add everything, what do you get? When you add everything, what do you get? So which means log to base 10 of 382 is equals to what? 2.558 to what?
2.
Put it direct in your calculator. Put it a block. Put it as a block. Log of 382. Is not the one member? Members, is it not the one?
It's the one.
Yes.
Is the one. Good. Any question, members, before we proceed? Any question?
No.
Okay. Which other question do we have there? Part C. Let's look at C. Let's look at C. Is what?
347.
47. The one log of this. Just know is log. Okay?
Yes.
We said this one is going to be first express this one. So 18,347 in standard form is the same as
1.8.
1.8347. You write everything like that, okay?
Yes.
Times the 10 to the power. What is the power?
4.
To the power?
4.
To the power 4. So after writing that, so it implies that log to base 10 of 18,347 is the same as log to base 10 of 1.8347 times 10 to the power what?
4.
The power 4. You break this one down. You break that one down. So log to base 10 is the same as 1.3847 plus, okay? Log to base 10 of 10 to the power what?
4.
10 to the power 4. So let's just put your calculator now. We have known how to use the table, not so?
Yes.
Just press for me that value. Press for me log of that. Log of 1.334. 1.8347. No, sir.
Yes.
0.263.
0.263. 3 what? 36 after rounding off to 4 decimal places. Not so?
Yes.
Plus, what is this? This is what?
4 plus
Plus 4. What do you get? You get 4.263.
6.
That is log to base 10 of 18,300 what?
7.
Prove your answer. Log 18,347. There we are. Have you seen? Have you seen?
Yes.
Yes.
Ask me, members. Ask me any question. Ask me.
No question.
Okay. If there are no questions, now I want to give you the names. Are you seeing here? A logarithm has 2 parts. Are you seeing that?
Yes.
Part A, the integer part before the decimal point is called the characteristics. It's called the what?
Characteristic.
Then the one after the decimal point is called the what? Mantista. It's called what?
Mantista.
Yes, mantista. Good. Which one? So I have 4. Let me write it big here. 4.2636. Okay?
Yes.
Yes.
This one. Are you seeing this one?
Yes.
That one is called what?
Characteristic.
Characteristic. Then the one that come after the decimal point, all of that. I think that all of that is called what? Is called what?
Mantista.
Is called mantista. Point noted? Members,
Yes.
point is noted, eh?
Yes.
Noted.
Very good, very good, very good. D. Let's look at D. We have 4 minutes. I think in 4 minutes we shall finish this. Find for me log to base 10 of 3094. 3094.
Shall I find it now?
Yes, right now. Do it. Don't even just send it to just send it to on the chat. Send it on the chat. Eh?
Okay.
If you don't know how to send it on the chat, then I will ask you direct. Following all the steps, follow all the steps, please. What's finished? Members, I'm waiting.
Yeah.
Members?
Yes, teacher.
What is the characteristic? Just tell me the characteristic from that. Don't even say anything.
Three.
Is 3. Then what is the mantista?
0.
0 point.
0.4.
0 point. 0 point. Is 4 point.
4.905.
No, it's 0 point.
Ah.
Mantista, the mantista. 0.490.
0.1.
0.5.
0.5.
0.5. You read well. So is what?
3.4905.
0.5. Okay.
Yes.
What about this one? Log to base 10 of. Let me say which one is this.
Peter, I have not understood that first
3, 4.
one.
Get for me the answer for that. What's the answer? Just tell me the answer. Ah. Someone is killing us with the background. Someone. Members, we have less than a minute. We have less than 1 minute.
Five point
5.72.
5.72.
7.5.
Very good. Before you are good. All right. I think we are together on that.
Yes.
Okay. So that's how we get logarithm for numbers which are greater than 10. So when